fact table itself. Now, there's a few things that as a data modeler, I would like to change. So like the RX key, the date key, and the month key all come out as doubles. So a double, sorry, and the product key and all the others. Like doubles are a numerical, construct. They take up more memory, they take up more space to store. And so I don't really want those to be doubles. So there's a few things I can do as a data modeler. I can come in here and then I should be able to change this to, instead of being a number, I actually want to be an integer. So we're going to see how this goes. So if I hit integer, 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 keep going, integer, integer, get to the end of the keys and then we'll be good. Integer, integer. And then if I hit preview from there, what should happen, if this is right, there we go. So you can see in the preview now that these keys no longer have the decimals because they're only ever going to be 0.0. They're just numbers in a database to link to another record. So you're never going to have a decimal place. You're not losing anything by trimming that off. You're saving space. You're making the performance, if this was a larger database, that the performance would be greater. And so by doing that, I have just made my life a chunk easier. If I come back here, now inside of the database, they will still be doubles, and I don't want them to be doubles. And so the other thing I want to do, because I want to be able to run this a bunch of times, I'm going to hit truncate table. Now, of course, most people don't want to truncate their table every time they run an ETL, but I definitely do. Because of how this works, you might, I don't know if I actually have to change this. So I'm going to truncate it. I'm going to hit the go button. I think we're still going to get decimals out the far end of it. So if I do that and then view output. Oh no, there we go. You can see the keys. They no longer have the decimals. Now we'll check this in the actual output data itself in a bit. I don't know if that's just being rendered like that. I missed demographic key. I don't know if that's being rendered like that because that's type of file column format has been prescribed, or if that's actually legit and they've changed it. But I'm going to go back here. I'm going to hit integer again, and then I can just hit the run button again. And basically that's going to drop and reload, truncate and reload that table on repeat. So you always end up with just that amount of data in there. If I didn't have truncate selected, then it would just keep on appending to the bottom, but of course then we'd end up with duplicate data. So I'm going to do this super fast, and then I'm going to copy, paste. I'm going to paste. I'm going to paste. Like I said, like the metadata driven element of this is far better. So, read up on that rather than just copying and pasting and duplicating a load of effort, if it makes sense. I mean, but at the end of the day, I'm just doing a one-off. So this is dim date. I'm going to hit OK. We're going to go and fix those keys as well on the other side in a second, so I'm not going to do too much at the moment. Dim date, dim product, edit, dim prescriber, dim geography. Dim pair and dim demographic. So over on this side, because we fixed up the keys on the other one, we then need to also change like date key to integer. We also want, well, that's actually a string because it's got Q in it. Month key, and that can be an integer. Month name obviously has a string in it, and day, well, you're never going to have a point of a day. Or if you do have a point of a day, I'll probably come and ask you what you're doing with your date modeling. So there we go. So I should be able to just prove that this still works. There we go. So now the keys don't have any decimals in them. edit this one, and we're going to have a look at the fields. So again, we've only got one in this one, and we'll only have one in the rest, I think. So hit OK and integer, prescriber. We're going to have a look at the fields. We've got prescriber key. So I'm going to hit integer, dim geography. Going to hit integer again, dim payer. And dim demographic. So if I, there we go. That one, and then as you recall from before, we join these together. There we go. And then there's various different types of joins in hops. So if you try and join something that it has a mismatch of columns, it'll warn you. If you try, you can also do hops on failure, hops on, positive loading of data. Obviously, that's also why it's called Apache hop. So if I hit OK, there we go. So hit the execute button again. And truncate table, that's fine. And then we go through the rest of these. So edit this one. This one we're going to call dim product, truncate table, SQL, execute, OK. Dim prescriber. Oop. SQL, execute, OK. Dim geography. Just all we're doing is just creating all these tables. Obviously once they're created, unless of course you add new fields, you never have to do this again. So this is just me setting up the environment that we are working in. Tell you what, I'm not going to create that one because then I can show you what happens if it goes wrong. So here's my ETL. And then I'm going to hit, well, first of all, I'm going to zoom in further down here so I can actually see the screen. I'm going to hit the go button, and this should deliberately blow up, I believe. There we go. So you can see here, like table output 7, I haven't labeled, I haven't created a table for it, so it's throwing a Postgres error. The rest of it, of course, ran. So you can see down here the output that finished processing. So we'll just go and clean that one up. And so super easy. If you see errors and what have you, obviously they're highlighted. I can execute that. Okay, that. Cancel that. Okay, that. And then if I do it again, I can, there we go. So this time it ran cleanly. And like I said about the different hop types, if I drop this one over here, for example, it's going to tell me that there's been an exception because the demographic output is just different in terms of its content compared to the payer output. And so you can't just send that into the same table without joining those streams together if you were going to do something like that. And so it stops you making silly mistakes. There's different ways to be able to send that stuff in. So if I just want to copy it in, you can see that it's labeled it. But now if I go and try and run this again, and I say yes to saving, you can see here that this time table output 6 is thrown up. This one's different because the table exists, but you've got this array out of bounds exception and the set values fail. And so you know that you've done something a little bit dumb. I mean, we also got warned about it, so we've done something a lot dumb. But if I delete that and hit the go button again, there we go. So, in this first section of today, we've gone from an Excel table, an Excel spreadsheet with 250,000 facts, like, pharmaceutical pricing facts, and all the associated data, and we've got to move that to a database. This database is dead simple. It is literally just Postgres. Using Postgres because it's been around since the dawn of time. It's open source and free to use in any type of organization. It's got extension points all over the place that allow you to then go and build out additional functionality or whatever. I read a a blog post from OpenAI the other week where they scaled to 800 million active OpenAI users using Postgres as the backend, and the engineering hurdles that they did to leverage that. And so, there's always scale. This will not, you do not have to use the biggest of big data platforms to be able to do something like this. Anything, short of, hundreds of millions of records will quite happily run inside of Postgres. Now, of course, you can use Databricks or another big data platform on small scale data. It just depends on your use case. But for something like this, we're keeping it simple. We're keeping the overhead simple. We're allowing for us to be able to leverage technology that's been around for a long time, because then there's a wider array of people that know how to use it, the support for it, and the way to be able to leverage it without depending solely on one data service provider. In this case, you will find, 1 trillion Postgres administrators around the world, but you could equally use MySQL. You could pick your other, your favorite database, MariaDB. I'm naming the open source-ish ones, but Oracle, whatever takes your fancy, whatever you have deployed internally, SQL Server, etc. Super simple, loading up a few records into the database.